we've just talked about sexual recombination. We've been talking about mutation. I think people have some familiarity, at least, with variation in rust pathogens and the importance of that variation from the point of view of breeding for resistance. All right, so the two lectures I'm going to talk about now deal with this point here, the fourth point here, and also the fifth point. All right, so if we look back through the history of understanding rust biology and variation in rust pathogens, I mean, there's been some very important discoveries that I've listed here, but it's really point number 4, this one here, and point number 5 that we're going to deal with now. Point number 4 is what we call between host specialization. All right, now this was discovered, as I showed in the previous slide, by a guy called Erickson, and really what he found was that you could take different isolates of a rust pathogen from different hosts and they showed specificity on those hosts. All right, so this is between host specialization, between wheat, barley and oats, for example. And the variants that we call, what we call these variants that show this between host specialization are referred to as formae speciales. And that's what, and I've already mentioned that in my first presentation. I showed you wheat stem rust and I called it Puccinia graminis forma species, tritici. And I showed you, I think, oat stem rust and I called that Puccinia graminis forma species aveni. All right? And then in the second part of the lecture, after lunch, we'll be talking about within host specialisation. So these are the pathotypes. This is where we come down to the concept of pathotypes, strains, or biotypes. But what I'm going to talk about now is this here, this between host specialisation, or the former species of rusts. If you want to read about this, there's a very nice 2-volume book that was published way back in the mid-1980s by Alan Rolfs and Bill Bushnell in America called The Cereal Rusts. In Volume 1, there's a chapter, Chapter 4, written by Dr. Annixter in Israel on the former species of rust. Dr. Annixter is probably the world authority on, or has been the person I think who's worked the longest on sexual recombination in rusts, and he's done a lot of work on former species.
And this will be in their package?
The 2 volumes? Good, because I was looking for, it was downloadable from the BGRI website and I was looking for that link and I couldn't find it. So you will be getting these 2 PDFs of these 2 books in the handouts, okay? And Chapter 4 in the first volume talks about the former species. So what actually is a former species? Well, we have had a recent change, I think you'd say, in perspective by the taxonomists, the fungal taxonomists. What I went by for many, many years, it was embodied in the International Code of Botanical Nomenclature. And this code really governed the taxonomy of all plants and fungi, right? And it allowed the use of the term former species within species for taxa that are characterised for their adaptation to different hosts and that are characterised scarcely or not at all from a morphological standpoint. So what this means is we can take 2 forms of a particular species that show host specialisation, but morphologically they are the same. They don't look any different in their morphology, but they are specialised to different hosts. All right? So this was the original definition of the former species. In 2011, at the International Botanical Congress in Melbourne, they replaced the International Code of Botanical Nomenclature with this, the International Code of Nomenclature for Algae, Fungi and Plants. And they actually had a revised statement about the former species, and they refer to it as an informal taxonomic grouping. So this is not a formally accepted taxonomic unit, the former species, like, for example, species or genera or phyla or order. All right, so it's informal. But the definition is very similar. So beyond that, which is adapted to a specific host, not necessary to specify morphological differences that distinguish this form. So again, It's in essence the same definition, but it's informal. Different isolates, specialised to different hosts that may or may not be different morphologically, usually not. So let's talk then about Puccinia graminis. I've already mentioned this. This is the causal agent of stem rust. Interestingly, this is a contradiction from my last lecture, but if you look at the studies that have been done on the evolution of Puccinia graminis, its primary host is considered to be barberry, not wheat. The reason that we say its primary host is wheat is because we as humans think wheat is more important than barberry as a food source. So that's what we would say an anthropogenic view. It's a view through the eyes of humans that wheat is the primary host. But in fact, from an evolutionary point of view, they believe that they believe that Puccinia graminis evolved initially on barberry, as a pathogen of barberry. And from barberry, it then spread to the cereals. They believe that it originated in Asia, and from there spread to other parts of the world, particularly concurrently with the spread of cereals as they became domesticated and the spread of agriculture. So Puccinia graminis, as a fungal species, can infect at least 365 cereal and grass hosts in 54 genera. It's got a very broad host range, right? But those isolates from all those different, from many of those different hosts show considerable host specificity. So if, for example, you take stem rust off oat, it doesn't infect wheat. In my experience, I don't know if Zach has ever seen this, but stem rust of oat infects oats. It doesn't occur on wheat. And conversely, stem rust on wheat doesn't infect oat. And yet those two pathogens, those two different forms of Puccinia graminis morphologically are almost identical.